Well, hello and welcome. In this presentation, we are going to look at perhaps one of the first applications of trigonometry, and that is working with angles of elevation and depression. Now, just as a recap for this lesson, you need to be comfortable identifying the names of the sides of a right angle triangle, such as hypotenuse, opposite and adjacent. Also comfortable with the names of the trig ratios. Sine theta equals the length of the opposite divided by hypotenuse. Cos theta is the length of the adjacent divided by the hypotenuse. And tan theta equals the length of the opposite divided by the length of the adjacent. And also a little bit of geometry. Should be comfortable with naming angle x, or calculating what x is. X is 56 degrees because it's an alternate angle. And angle B is 40 degrees as it is vertically opposite this angle over here. Now, the angle of elevation. Basically, when I see the word elevation, I think of moving upwards, just like this fella here walking up the steps. And it can be defined by this fairly long definition. Give you an opportunity to read that, which can be represented by this picture here. The angle of elevation effectively is this angle here. It's the angle between your eye, the observer's eye, which is along the horizon, and an object that happens to be in the sky. As an example, you see the kite here is flying. Length of the string is 100 meters. The angle of elevation is 52 degrees. It's the angle between the horizon, which in this case is the ground, and the kite in the sky. So there you go. The angle of elevation is 52 degrees. All right, the angle of depression. Now, depression I like to think of as looking downwards. So you'll see here, this time we're going down some steps. And another definition here, but I prefer just with a picture. If my eye here, the observer's eye is here, and the horizon is there, the angle of depression is this angle here looking down towards an object. So here's an example. Here I am in a plane. I can see a forest down here. The angle of depression is the angle between the horizon and this angle here. Which is the line of sight, the angle towards the trees. Now I'm going to ask you, if that there is 30 degrees, what is angle theta? Just think about that for a second. Of course, it is 30 degrees. Why so? Well, there you go. Because of the nature of alternate angles. And that was a little bit of that starter question that I had. Now, what we'll be moving on to next is just working through two examples. One working with an angle of elevation, one working with an angle of depression. So, first one, we're going to work with an angle of depression. Now, let's just read the question, because quite often these questions are written and you do not always have a diagram. So, let's read the question. An observer in a balloon flying at an altitude of 91 meters sights an object in the middle of a field at an angle of depression of 16 degrees. How far must it fly to be directly over the landing spot whilst remaining at an altitude of 91 meters? A lot of words there. Fairly straightforward picture though. Here I am in a balloon. I see an object. There's an object. And I have an angle of depression of 16 degrees. In other words, I have 16 degrees. Now, I need to construct a right angle triangle out of this. So, So here's my right angle triangle. If that was the 16 degrees, that there would also be 16. You see here, 16 degrees there. I'm making a right angle triangle which is going along here. There, there, and there. That is my right angle triangle. So I'm to remain at an altitude of 91 meters. How far do I need to travel? How far do I need to travel? I'm looking to calculate this distance here. Now, we'll just go to the next page and we'll actually do our calculations with trigonometry. So, we've got our picture of our triangle. Do we know our knowns and unknowns? Well, 91 meters is a known, x is what I need to calculate, and 16 degrees is also a known. We need to name the sides of our triangle. So, first side, the side that is opposite or across from my reference angle, is the opposite. The other side, which is between my reference angle and my right angle, is called the adjacent. Now, I need to identify the trig ratio that has opposite and adjacent. Well, the one with opposite and adjacent is tan. So there we go. I always like to write out my trig ratio. It demonstrates that I have an appreciation of what I'm really trying to do here, and it eliminates errors when I start to transcribe or the actual knowns and unknowns into the formula. So tan theta equals opposite divided by adjacent. Now I need to populate with knowns and unknowns. So the tan of my angle equals the length of my opposite divided by x, and I just rearrange that formula and then use my calculator to solve. So x will equal 91 divided by the tan of 16. So all I've done is just swapped these two around. So I moved the x up to there and tan of 16 over there. And then I just put that directly in my calculator and I'll end up with an answer of 317.35 meters. I've just given an answer to 2 decimal places. I'll move on to the very last example that I'm going to go through today. Oops, here we go. Right. Now, our next example is working with an angle of elevation. If you recall, that's an angle in which we look upwards. Now, reading the question, a sailor 320 meters from the base of a 25-meter lighthouse looks up and waves to a friend at the top of the structure. Find the angle of elevation from the sailor to the top of the lighthouse. Well, I'll draw a picture here to represent this in reality. Here's my sailor in their boat, or is that a ship? I'd probably say it's a boat. 25-meter lighthouse. They're looking upwards, so there's an angle of elevation in here, and they are 320 meters from the base of the lighthouse. Okay, so we can represent that quite simply with a right angle triangle, and there it is. So, and just going through our steps, we've got our picture of our right angle triangle. Identify the knowns and the unknowns. Unknown is my angle. The knowns are the 2 lengths here. All right. Name the sides of the triangle. Well, this side here is opposite because it's opposite my reference angle. This side here is between my reference angle and my right angle, so it is adjacent. And the trig ratio that involves opposite and adjacent is tan theta. Tan theta equals opposite divided by adjacent. I will now populate the values of knowns and unknowns into that ratio. Tan theta equals 25 divided by 320. And then I'll just solve using my calculator. Theta equals the inverse tan of that fraction there, equals 6.24 degrees. Again, I've written this to 2 decimal places. So there you have it. I hope this presentation has assisted you in understanding the angles of elevation and depression, and these two examples will provide you with an even better understanding for the future. So until next time, good maths.